we're going to look at inverse functions. And this is some function, okay? And they've given it to us like this. This is a quadratic function, and this is kind of written in its vertex form. The vertex really gives us a good idea of where the vertex is. Essentially, this vertex is at -2 and -1. Is that familiar?
Yeah.
Yeah? Okay, good. So we have a vertex at -2, -1. And because the a value is 3, that means it's stretched, so it's much thinner than an a value of 1 by a factor of 3. Okay? An inverse function, and you can think of it like this, is taking the idea of if this was y when we're graphing, right? We're used to seeing this as y. We're going to replace this with y, like we usually do. But now what we're going to do is we're going to interchange it with the other variable in the equation, which is our x. And we're going to swap places within equations. Okay? So, well, what's going to happen is we're going to have x is equal to 3y plus 2 squared minus 1. Okay? And what this is all going to solve, and how we write this in function notation, is the inverse. So f to the power of -1 of x. That's what this is right here. Okay, so this is the inverse of the function. And writing in function notation lets us know the relationship of our new function to the original one. We know it's an inverse, where if we just switch x and y, it looks like it's two completely different equations. So that's one of the benefits of function notation, is we can communicate about general ideas. Okay. Now, to actually find the inverse function, we still want to set it equal to y. So we have to go through the process of isolating y. Okay. So the first thing I'm going to do is kind of like a reverse bedmaster. We're going to bring -1 back to the other side. So that will read x plus 1 is equal to 3y plus 2 squared. Does that make sense?
Yeah.
Okay. The next thing we want to do is we want to move this 3. And because it's multiplied by, when we bring it over, we're going to have to divide by 3. So we're left with x plus 1 divided by 3. Okay, and I'm going to show you another way to represent that, just so it helps us later on with transforming functions. Okay, is equal to y plus 2 squared. Okay. Now another way I can write that, so I'll do it kind of on the side in purple here, is I can actually write that as x over 3 plus 1 over 3. Okay, and technically that could also look like, or 1/3 x plus 1 over 3. Okay, so I want you to think of that. I'm going to rewrite it that way after. But just keep this in mind when we go to talk about how it's changed from where it originally was. Okay, so in order to get this square root to the other side, we take the square root of this entire function. So we have the square root of x plus 1 divided by 3 is equal to y plus 2. And finally, to move the 2 over, we take the square root of x plus 1 divided by 3. And technically, this 2 is now outside of this part. Subtract the value of 2 equals y. So this is, I'm going to switch sides now, the inverse. -1 is equal to the square root of x plus 1 divided by 3 minus 2. Okay? I'm going to take these ideas and I'm going to sketch it on a graph. Okay? So we've just found our inverse of the function. And what's important is whatever the x and y values were before, on our new graph, they're going to change. They're going to invert. So here's our original one, right? We said we had a vertex of -2 and 1. These are x-intercepts, not as important for what we're doing right now. But our new function, as we said, was the square root of x over 3. Oh my, I was pushing the wrong button. Plus 1 minus 2. Right? And if you notice here, unfortunately, it won't show because it only shows it in function notation. Can I do this? Yeah, it'll still do that. I wonder. We'll talk about that after. Okay, so here's our original function. Here's our new function. Okay. Now, if you notice our new function, do we need to talk about? Yeah, we should talk about this. Okay, so our new function here. Here was our old one, our vertex at -2 and -1. I'm just going to bring something up here. Okay. And -2 and -1 are what looks like our new vertex. It's not technically a vertex, is actually at -1 and -2. Okay, so they've switched. And essentially the idea here is what has happened, and I'll try to do it as best as I can, but we've flipped, and maybe I should change the color here. Oh my, blue. Okay. We've flipped on a line coming through here. Okay, I'll just erase what we had. Okay, so our function, think of it as it's, when we do lines of symmetry, this symmetrical line is on something like y is equal to x. So that's the slope or the graph of that line. So it's flipped. So the vertex points have changed from -2 and 1 to -1 and 2. Okay. Now because this program is technically drawing functions and it won't draw all the way over here, I think I could. Give me 1 sec. Okay, I was able to redraw it, and if you see what I did is I essentially just switched our x and our y value, and it actually drew the entire function where it was inverted on that line. This is important because what you'll see is that the vertex of the function has 2 different points, and also you'll notice our x-intercepts have actually changed also. This one was at -2.577, and this is actually now a y-intercept, okay, because the x and the y zeros have switched, and the y value is at -2.577, and same with our other x-intercept. So coordinates along any function when you invert it, essentially the x and y value, so here's the x value, it turns into the y value, and the y value turns into the x value. They constantly flip back and forth, okay?